All right, we're moving on to video 10.2.2. This is a video I really need you to engage in and to decide that if you have questions that you can identify where they are exactly. So at no point should you be tuning me out or just writing what you see on the screen. You really need to be thinking about each step and pausing to make sure that you understand it, because this is a completely new operation. I'm not saying this to scare you, I'm saying this that you need to have your eyes and your ears open and be engaged in this. So what we're going to be doing is we're going to be looking at an introduction to log functions, because coming up soon we're going to be graphing these, but we really want to understand what it is that we're graphing and where we're going with it. So we're going to get started, and we'll start by defining what a logarithmic function is. Now the abbreviation for logarithmic is just, we call them logs, L-O-G, but this is their full name, just like trigonometry we sometimes call trig. Okay, so what we start with is y equals log this little b and this x. And I'm going to start with the pronunciation. This is pronounced log base b of x. Now that base b is absolutely intentional, because we're in the chapter where we're talking about exponential functions and logarithmic functions. There must be a connection. The connection is that they are inverses. So we're going to start with this exponential function right here, and we're going to take the inverse of it. Now, we already have it as y equals, which is often step one, from f of x to y equals. The second step would be to switch the x and the y, and that looks like this. But the question now is, how do I solve for y if y is in an exponent? How do I solve for y if y is the exponent? Well, we use logs. You see, logs say that the exponent up here equals log base b of x. This is a way to solve for the exponent. Okay, so if we don't know what an exponent is and we can't figure it out, okay, for example, if I have something like 5 to the power of x and it turns into 72, and I think 5 can't turn into 72 using a very simple exponent, how is it going to happen? 5 times 5 is 25, times another one is 125. So how am I going to find this? Well, to solve for that exponent, I would use a log. Okay, so my exponent is equal to, in this case, x is the exponent. The base is b, is 5, and then we say 72. So this thing right here is an operation. Okay, it's an operation. It's not equivalent to any of the following, but it's an example of. So I'm going to say this. It's like a square root. It's like an absolute value. It's addition, subtraction, multiplication, an exponent. It is an operation that you can do to numbers. And the operation, its purpose is to find an exponent. Okay? So if you can understand the purpose of a log is to find an exponent, it's going to make things a lot easier. So maybe write that down a couple times, what the purpose of a log is. All right, so we're going to be using this mentality. When taking the log, okay, of a known base, so this is my known base, my base is 5, my base is 2, whatever my base is, of a certain value, so here's my value. So I'm taking the log with a base of a value, the outcome is the exponent. That's really important. The outcome is the exponent. All right, so I have b to the power of p equals v. Okay, this would be written in exponential form. The base is still b, the power is p, the value, okay, is v. So I can go interchangeably between these two. One may be more useful than the other. What's also important is to keep in mind that b and v are always going to be positive. My base is always going to be positive. My outcome is always going to be positive. My power, however, can be negative. My power can be negative. And that just allows us to take the reciprocal and flip things over. So let's take a look. So in this case, you're asking yourself, what is the exponent? Because all of these are equaling the exponent. So if I give you this expression, your question is, what is the exponent? So the relationship between these two numbers is what's in question. So from 5 to 25, we're asking, what is the exponent? The answer is 2. Next one. I'm saying 10 to what power? Again, what is the exponent? Is 1,000. The answer is 3. In this case, 2 to what power is 32? The answer is 5. Very good. I'm leaving some time because I want you to do the thinking and not just waiting for me to say it. Because as soon as you start thinking in this mentality, the easier these are going to get. Okay, so here I've got a special one. I've got 1/2 as my base. To what power is going to equal 4? So the question is, how do I take a half and I turn it into this whole number? Well, I would start by looking at the 2 in the denominator, because 1 over something, really it's the something we need to look at. So the relationship is that it needs to get squared, but it also goes from this fraction to this nice whole number, which means that my exponent is -2. That flips it over. Here, I'm saying 3 to what power results in 1 over 27? Again, I look at the relationship between the 3 and the 27. I consider the fact that it's a 1 over 27, which means I must have used a negative in order to get it into the denominator. That means -3. In the last one, I'm taking 4/9 and I'm considering what power is going to get me to 2/3. Well, the 4 and the 2 and the 9 and the 3, those remind me of square roots. Well, what exponent represents square roots? That's right, it's 1/2. Again, the question we're asking is, what is the exponent? All of these can be done without a calculator when we ask ourselves that question. Does it mean that there's going to be some that we cannot do with or that we have to use a calculator? Absolutely. There's going to be plenty where the exponent is not able to be found unless we had a technology to do it for us. So let's go ahead and keep going. We have 2 special types of logs. The first special type of log is called common log. Now we have these for a couple purposes. One of them is that in math we like to have a shorthand. We don't want to write everything. For example, we don't write a 1 in front of an x if we mean 1x. We also don't write an exponent of 1. It's just assumed to be there. So we use a shorthand of 1x to the power of 1. We don't write all those 1s, we just write x. Okay, this is a shorthand. Okay, it's a notation that allows us to write fewer marks, and for mathematicians this is really important when they're doing long proofs of some deeper mathematics. So that's one reason. 2 is that it allowed us to put something on the calculator that takes a log very quickly. Now this log that we have, common log, the shorthand is we don't even write a base. Well, what base is it? It's log base 10. It's always log base 10. So if you just see log of 5, that means, what it means is log base 10 of 5. We just don't write the 10. So this question would be asking us 10 to what power equals a 5? 10 to what power equals 5? Well, I need a calculator to figure that out. So why don't you grab your calculator and why don't you type into your calculator just the log, and the log it's over on the left hand side towards the bottom, and you'll find it there, and just press log 5 and see what happens. Well, my outcome for log 5 is, and you're going to get a long decimal because it's irrational. This is another thing that produces irrational numbers. Okay, and mine is, I got 0.69. We all should have had the same thing. Why am I saying mine? 0.699897. Okay, so there's 5 decimals. Oh, hello. I don't need you. So we can continue to this. I can say, well, what is log of 37? Again, that's asking the question 10 to the power of what equals 37? Once again, I have no idea. So we would just type in log 37, and you're using the common log. So I don't need to write the base 10 to find this. And log 37 is approximately 1.56820. So then there's 5 decimal places. I just stayed consistent. The second type of special log is the natural log. And the natural log, we've talked about e before. It has a base of e. And remember, I'll just remind you that e is 2.718281828, and that's only to the first 9 decimal places. But this is our approximation of e. So this is, again, assumed that the base is e. And the way we write natural log is ln. Now I know that looks like log natural, but it is the natural log. So I can write natural log of 3. Well, what does it mean? It means e to the power of something is going to result in a 3. Once again, how am I going to turn this thing into a 3 using an exponent? I need a calculator to do it. So go ahead, and that natural log button should be right below. And you're just going to take the natural log of 3, and the outcome is the natural log of 3 is approximately 1.09861. Okay, so there's 5 decimal places again, and that gives me the natural log of 3 is 1.09861. So if you were to take e and raise it to the power of this thing that just came up in your calculator, you would get 3. Now, if you use an approximation of your answer, you'll get an approximation of 3. You'd have to actually use the answer that's in your calculator. So we'll talk more about those two tomorrow, but it's important to recognize that if I just write log or if I just write natural log, that you understand that those bases are assumed and do not have to be written. All right, great job with those.